Yeah, welcome back. So now we are going to study about some standard type of distribution, and first we will study uniform distribution. So what will be given in the question, that your continuous random variable x is uniformly distributed between a and b. This is what is given in the question. Your random variable x is uniformly distributed between a and b. That means between, like, x will take values from a to b. X will take the value from a to b, and in between a to b it will give you a constant value of pdf. Your pdf will have a constant value. Your pdf will have a constant value. So at all the point the pdf will have a constant value. Does that mean that probability is same at all the point? What if, let's just say, this point is alpha? What if I ask you probability such that x is taking, probability such that your random variable x is taking value alpha? What will be the answer? K. No, that would be 0. No, in case of continuous random variable, probability at a point is 0. But if you are asking me fx of x equals to k, sorry, fx of x equals to alpha, that what is the value of your pdf at x equals to alpha? That value is k only. So uniform distribution means the value of your pdf, the value of your probability density function, that is constant between a to b. Is that okay for you? So that's why the name is uniform distribution. Now can you let me know what will be the value of this constant k? Yes, I can surely let you know what will be the value of this constant k, because I know that this particular thing should throw 1. So what is the area of this particular thing? This is like a rectangle, right? So k into b minus a, total area is k into b minus a, that is equals to 1. So k is equals to 1 upon b minus a, right? So basically your fx of x is 1 upon b minus a, where your x is going from a to b and it is 0 otherwise. So if only this particular thing is given, if only this thing is given, then you should be able to understand all these things on your own. You should be able to make all these things on your own, that your random variable x is uniformly distributed between a to b, uniformly distributed between a to b. So amplitude also you should be able to write down whatever the length you see here. What is this length? This length is b minus a. Whatever the length you see here, 1 by this length would be your value of k. So 1 upon b minus a. So it would be equals to 1 upon b minus a between minus a to b, otherwise it will be 0. All good, all fine, very simple thing. Can you make its CDF? What you are making? This is your PDF, right? From PDF to CDF you need to go. So what is the path do you follow? Your capital fx of x would be equals to what? Minus infinity to x fq of q dq, right? So basically you need to integrate this particular graph. You need to integrate this particular graph. So do you know how to integrate? You should know how to integrate. So till a everything is 0. Integration of 0 is 0 only. After that what is happening? There is a sudden jump of 1 upon b minus a. So there will be a slope of 1 upon b minus a. So there will be a slope of 1 upon b minus a. And after that there is a decay of 1 upon b minus a. So whatever the slope was there, slope was 1 upon b minus a. 1 upon b minus a. So now whatever the slope was there, that will lose its slope. That means now the slope would become 0. So basically simple integration is there. If you have studied your signals and system, then you would be able to do this integration very simply. Very simple integration it is. This point is b. So initially 1 upon b minus a slope, and then slope becomes 0. 1 upon b minus a, then slope becomes 0. So what is the slope here? Slope here is 1 upon b minus a. So if this slope is 1 upon b minus a, what will be this amplitude? This will be 1, right? Because this length is b minus a. Basically, let's just say this length is y. So y upon b minus a is equals to slope. So y is coming out to be 1, and it is pretty obvious as well, because fx of infinity should be equals to 1 only, and we are getting it 1. So you should be able to know how to integrate. So if your PDF is given, you know how to find out the CDF. Well and good. Let's try finding the statistical parameter. So first we will find mean of random variable x. What we are finding? Mean of this random variable. So mean of this random variable x, that will be equivalent to minus infinity to infinity x into fx of x dot dx. So it is non-zero between a to b. It is non-zero between a to b. X into, what is the value of fx of x? The value of fx of x is 1 upon b minus a dot dx. So 1 upon b minus a goes outside, x square by 2 a to b. So 1 upon 2 into b minus a into b square minus a square. So how will you open it up? B minus a into b plus a, right? How will you open it up? B minus a into b plus a. So this will be opened as b minus a into b plus a. And here you can see that this b minus a and b minus a is getting cancelled. So expectation of x is coming out to be a plus b by 2. So this is your expectation of x. Okay, a plus b by 2. So right in the middle of this, let's just say this was minus 1 and let's just say this was 4. So first let me know what will be the value of this k. This width is 5, so upper width should be 1 by 5. So value of k would have been 1 by 5. And what if I ask you what is the mean? So mean will be 4 minus 1 divided by 2. This addition with this divided by 2. So mean will be 3 by 2, which is 1.5. So mean will be 1.5. Okay. So expectation of x is a plus b by 2. Well and good. This you should be remembering. What about mean square value? So mean square value we will find out, but you don't need to remember it. Whatever the answer we get, you don't need to remember it. So mean square value we will find it out. So what we need to do? X square fx of x dot dx. What is fx of x? 1 upon b minus a. And it is non-zero between a to b. Right? So 1 upon b minus a. X cube by 3. A to b. So that is coming out to be 1 by 3 into 1 upon b minus a, b cube minus a cube. So do you know the formula of b cube minus a cube? B minus a into b square plus ab, right? So this formula I am going to apply now. B minus a into b square plus a square plus ab. So what you are getting? Basically your expectation of x square is coming out to be, just 1 second guys, yeah, so it is coming out to be a square plus b square plus ab divided by 3. So this is your expectation of x square, which you don't need to remember, so I am not putting it in a box. Okay, but variance answer, whatever the answer of variance you will be getting, that you need to remember. So what is your variance? That is your expectation of x square minus expectation of x whole square, right? So expectation of x square is a square plus b square plus ab divided by 3 minus, what was your expectation of x? That was a plus b divided by 2. So what you will do? A plus b divided by 2, and you need to do the square as well. So a square plus b square plus 2ab divided by 2, so this will become 4. So what is the LCM? LCM is 12. So 4a square plus 4b square plus 4ab minus 3a square minus 3b square minus 6ab. So what you are getting? A square plus b square minus 2ab divided by 12. So that can be written as b minus a whole square divided by 12. So what you are getting? Sigma x square is coming out to be b minus a whole square divided by 12. Should be remembered, okay? Should be there in your mind. So your variance is b minus a whole square divided by 12. And if someone asks you what is the expectation, so expectation is a plus b divided by 2. This is the expectation. So these two things are there, variance and expectation. Expectation is a plus b divided by 2 and variance is b minus a whole square divided by 12. So let's just say if I say my my random variable x is a uniform random variable which is uniformly distributed between -2 to 3. Now if I ask you what will be my expectation, so what you will do, you will add both of them divided by 2. So expectation of random variable x will be 1 by 2. And if I ask you what will be my variance, so what you will do, you will see the width. What is the width? 3 minus -2. So total width is 5. Do the square divided by 12. So 25 by 12, that will be the variance. And if I ask you the mean square value, then you will calculate the mean, you will calculate the variance, and from there you can find out the mean square value as well. Is that okay for you? Well and good. So we will surely solve a question. So as of now, in this particular lecture, what you have studied, so there is something called uniform random variable. That means it will be uniformly distributed between two values. Those two values will be given. From that you should know what will be the magnitude of your fx of x. That magnitude will be uniform between a to b. Otherwise the magnitude will be 0. Amplitude will be 0. Otherwise the amplitude will be 0. And how to find out this particular amplitude? That would be simply the 1 upon of your width. So whatever the width you get from here, 1 upon that width will be the amplitude of this your PDF. From PDF to CDF you know how to get, just by simply integrating you will get the CDF. Mean of random variable x is coming out to be a plus b by 2, and variance of random variable x is coming out to be b minus a whole square. That means width whole square divided by 12. Width whole square divided by 12. Right? Now what if your PDF is symmetric about the origin? What is the meaning of that? Symmetric about origin means your random variable x should be uniformly distributed between minus alpha to plus alpha. That means it is symmetric about the origin. Okay? Minus alpha to plus alpha. Uniformly distributed between minus alpha to plus alpha. Right? And what is the amplitude? 1 by 2 alpha. Very simple. Because what is the width here? This width is 2 alpha. If you want to make the whole area equals to 1, if you want to make the whole area equals to 1, that means this has to be 1 by 2 alpha. Because 1 by 2 alpha into 2 alpha will be 1 only. Right? So the amplitude is 1 by 2 alpha. What do you think? What will be the mean? Do you remember the formula of mean? Yes. A plus b divided by 2. So minus alpha plus alpha divided by 2. 0. So always mean is the middle point. In case of uniform random variable, mean is the middle point. Here also it is the middle point only, no? A plus b divided by 2. Middle point. A plus b divided by 2. And here also it is the middle point. Minus alpha, alpha. What is the middle point? 0. So mean of random variable x is 0. And what about the variance? What is the variance? Variance formula was b minus a whole square divided by 12. So total width. What is the total width? 2 alpha. 2 alpha whole square divided by 12. So 4 alpha square. So basically you will be getting alpha square by 3. So this is the variance. So for a PDF, for a uniform random variable, for a uniform PDF which is symmetric about origin, the mean is 0 and the variance is alpha square by 3. Okay? You don't need to remember it. You will be able to derive it very easily. Very easily you will be able to derive it. You don't need to mug it up. Right? You don't need to mug it up. Well and good. Now x is a random variable which is uniformly distributed between -2 to 3. You need to find the mean square value and variance. So what we know, we remember the formula of mean. What is the formula of mean? Formula of mean is b plus a. Basically this is the value of your a. This is the value of your b. So for finding the mean, I just need to find the middle point. So what will be our middle point? Middle point will be b plus a divided by 2. So answer is 0.5. What I need to find? Variance. So what is the formula of variance? Whatever the width is there. What is the width is there? Width is 5. Right? Width is 5, no? 3 minus 2. So width is 5. So width square b minus a whole square divided by 12. So what is the answer? 25 by 12. And what they are asking now? Mean square value. So mean square value is given as sigma x square plus mean square. Square of mean. variance plus square of mean, AC power plus DC power. So what is the AC power? 25 by 12. What is the DC power? 1 by 4. 28 by 12. This is the answer you are getting. Okay, very simple thing, very straightforward. Uniform random variable is very straightforward, right? Now x is a random variable. X is a function of another random variable theta. Okay, x is also a random variable, theta is also a random variable. X is also a random variable and theta is also a random variable. Now about theta, what is given? That random variable theta is uniformly distributed between 0 to 2 pi. Random variable theta is uniformly distributed between 0 to 2 pi. So if this information is given, can you draw f theta of theta? If this particular information is given that it is uniformly distributed between 0 to 2 pi, so can you draw f theta of theta? Surely you can draw. Between 0 to 2 pi, it is uniformly distributed between 0 to 2 pi. Uniformly distributed between 0 to 2 pi. So what is the width? Width is 2 pi. So here what should be the height? 1 by 2 pi. So 1 by 2 pi into 2 pi, what will be the area you will be getting? That is 1. So you need to find the variance of x. What you need to find? You need to find variance of random variable x. So I need to find variance of a random variable x. So that would be equals to expectation of x square minus expectation of x whole square. But you are not given the PDF of theta. Sorry, you are not given the PDF of a random variable x. You are given the PDF of theta, not the random variable x. So what you will do? First, let's try finding expectation of x square. So expectation of x square would be equals to, there is a relation between x and theta. So what you will be getting? X would be equals to, sorry, x square would be equals to 9 cos square theta. 9 cos square theta. Right? So 9 should be outside. E into cos square theta. Say yes or no. Is that okay for you? Expectation of x square I am finding. I am not having the PDF of x. So what I need to do? X is 3 cos theta. So 9 cos square theta. Why I am doing so? Because I am having the PDF of theta. If you are having the PDF of theta, then your job will be done now. 9. Expectation of cos square theta you need to find. Expectation of cos square theta. So what you will do? Whatever that is inside, that you write down dot d theta. Whatever that is inside. Now this is a function of theta. So you would require the PDF of theta as well. All good? All fine? So 9 going from 0 to 2 pi. F theta of theta going from 0 to 2 pi. Cos square theta. What is the magnitude of f theta of theta? That is 1 by 2 pi. 1 by 2 pi. 1 by 2 pi. Dot d theta. So 9 by 2 pi. 9 by 2 pi. Integrating 0 to 2 pi. 9 by 2 pi integrating 0 to 2 pi. 1 plus cos 2 theta divided by 2 d theta. Right? So what is the answer you will be getting? 9 by 2. You can solve this integration. If you solve this integration, what you will be getting? If I solve this integration, 9 by 2 pi. So here this will throw 0, 1 by 2 and 2 pi. So basically I will be getting 2 pi by 2. You can solve this integration, okay? 1 by 2 into theta plus 0. This is what I will be getting. And limit of theta is going from 0 to 2 pi. So 2 pi by 2 you will be getting. So from here you can see that 9 by 2 will be the answer. Did you understand this point? Expectation of x square I needed to find. X is a function of cos theta. So 9 cos square theta, 9 goes outside. Cos square theta, f theta dot d theta I can write down because this is the function of theta now. Now f theta of theta I am already having, which is 1 by 2 pi between 0 to 2 pi. So I just need to integrate now. So that integration I will get as 1 by 2 into 2 pi. So 1 by 2 into 2 pi I was getting. So 9 by 2 is my answer. So expectation of x square is coming out to be 9 by 2. Okay. Now I need to find expectation of x. So what I need to find? Expectation of x. Again I am not having the PDF of random variable x, right? So but I know that x is equals to 3 cos theta. X is equals to 3 cos theta. Right? X is equals to 3 cos theta. So now what I can do? Whatever that is inside whatever that is inside, write it down in a smaller manner. Now this is a function of theta, so you would require the PDF of theta as well. F theta of theta is non-zero between 0 to 2 pi into 3 cos theta divided by, what is the value? 2 pi. Now if you integrate it from 0 to 2 pi, what will be the answer? Cos theta 0 to 2 pi. 0, this point is pi, this point is 2 pi. So whatever the positive area is there, the same negative area is there. Basically for one cycle you are integrating your cos. What will be the answer? 0 only, no? So you can integrate this particular thing, very simple, your answer will be 0. So expectation of x is coming out to be 0. So expectation of x is 0, expectation of x square was 9 by 2. So what they are asking? Variance. So variance would be equals to expectation of x square minus expectation of x whole square. So variance would simply be expectation of x square, which is 9 by 2. Very simple, right? Very straightforward. Just follow the process, whatever that has been told to you, just follow that particular process and your answer will be done. Very simple thing, very straightforward. Next we need to study about Gaussian distribution, or you can call it normal distribution. So what will be given? That x is a Gaussian random variable. What will be given? X is a Gaussian random variable. Gaussian random variable with normal distribution. Because of normal distribution you use the sign n. Here what was the sign you were using? You are using the sign u, uniform distribution. So here because of the normal distribution you use the sign n. So x is a Gaussian random variable having mu x mean and sigma x square variance. So here in the bracket whatever that is written, first value will be mean, second will be variance. If somewhere it is written that x is 2, 3, what does that mean? That expectation of x is 2 and variance of x is 3, and type of random variable is Gaussian, type of distribution is Gaussian. So it is a Gaussian random variable with 2 mean and 3 variance. So mean and variance would be written in the bracket of n. Okay. Now what is the distribution? So here what was your fx of x? Fx of x was 1 upon b minus a, right? 1 upon b minus a from a to b, not minus a to b. 1 upon b minus a from a to b. It was 1 upon b minus a. So here what it will be? It will be 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, e to the power x minus mu x whole square, and then divided in the e to the power only. Basically it is being divided in the e to the power only, divided by 2 sigma x square. Are you able to understand this point? 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square 2 sigma x square. So this is your fx of x. This is your fx of x. Sir, do we need to remember it? You need to remember it. This is the mean, mu x is the mean and sigma x square is the variance. Basically mean is mu x and variance is sigma x square. Okay, we need to remember it anyhow. So what will be the amplitude at x equals to mu x? What I am asking, I am drawing the graph of fx of x. So at x equals to mu x, what you will be getting? X equals to mu x. So if you put mu x here, what it will be there? It will become 0. So e to the power 0 is 1. So at x equals to mu x, let's just say mu x is here. Let's just say this is your mu x. So at x equals to mu x, your amplitude will be 1 upon under root 2 pi 1 upon under root 2 pi sigma x square. So this completely is there in the under root, okay. So at x equals to mu x, the amplitude is 1 upon under root 2 pi sigma x square. And what will be the magnitude or what will be the amplitude at x equals to infinity? What I am asking, fx of x equals to infinity. If you put x equals to infinity here, what will happen? whatever the amplitude is there, I don't care, e to the power minus x equals to infinity square, whatever that is there downward, I also don't care about that. Basically it is becoming e to the power minus infinity, what that would be 0. And similarly what will happen for fx equals to minus infinity? So e to the power minus infinity whole square divided by 2 sigma x square. So e to the power minus infinity square, that would be infinity square only, divided by 2 sigma x square, so that would be equals to 0. So at plus infinity and minus infinity, at both of the part it is 0 only. So basically what is happening, at this particular point it is the maximum. At x equals to mu x it is maximum, and after that, so this is how the graph will go. This kind of a graph you will be getting. So this is your normal distribution. Okay, and you can calculate this particular thing, minus infinity to infinity fx of x dot dx. It will surely come out to be 1 only. If I say one thing, that sir, minus infinity to infinity e to the power minus x square dot dx is equals to under root pi. Do you agree to this point? Right? You agree to this point. Now if I ask you minus infinity to infinity e to the power minus x minus 2 square dot dx, what will be the answer of this? Under root pi only, no? In place of x I am putting x minus 2. So x minus 2 if you put equals to t, what you will be getting? Dx equals to dt. Limit will also be from minus infinity to infinity. So eventually you will be getting e to the power minus t square dot dt, which is equals to under root pi only. So you are just shifting the graph. You just shifted the graph. Here the origin, here the maximum amplitude was at t at x equals to 0. But now here the maximum amplitude will be at x equals to 2. If you put x equals to 0 here, what you will be getting? 1. If I put x equals to 2 here, what I will be getting? 1. So basically previously the graph was some e to the power minus x square. The graph was like this, e to the power minus x square. But e to the power minus x minus 2 whole square, the graph would be like this. Nothing else. The area under the curve does not change. The area under the curve is not changing. Area under the curve is still under root pi. So this is still under root pi, right? So just think about it, what it will throw. Just think about it. Will it throw 1 or not? Will this particular thing throw 1 or not? So let me know. What I need to do? Minus infinity to infinity. This is a constant amplitude, 1 upon under root 2 pi. Sigma x square is a constant value. Variance will be a constant value, right? Here variance is coming out to be a constant value. Always variance will come out to be a constant value. Here I am putting x just to show that it is the variance of random variable x. Variance of random variable x. That's why I am putting sigma x square. So all this thing is a constant part. So all this thing is a constant part, right? E to the power minus x minus mu x whole square divided by 2 sigma square dot dx. Now you know that e to the power minus x square dot dx will throw under root pi integration. Now x minus mu x whole square e to the power x minus mu x whole square dot dx, what it will throw? It will also throw under root pi only, right? Just it is shifted, just the graph is shifted to mu x, nothing else. So it will also throw under root pi only. But if I divide it by 2 sigma x square, so I told you one thing, e to the power minus x square by 2 will throw under root pi, whatever that you see downward, take it in the under root. So what it will throw? 1 upon under root 2 pi sigma x square is already there. So e to the power minus x minus mu x will be throwing pi, but whatever you see downward, take it in the under root. So 2 sigma x square pi, 2 sigma x square pi, this and this get cancelled out. What is the answer you are getting? 1 only. So yes, it is a PDF, it has to throw the total area equals to 1 only. So yes, the total area was 1. So I don't think it will be too tough to remember. Do you remember the Q function? Do you remember the Q function? What was your Q function? 1 upon under root 2 pi going from x to infinity e to the power minus x square by 2 dot dx. Here there is no integration. This is simply fx of x. So 1 upon under root 2 pi sigma x square e to the power minus x minus mu x. Basically center is moved to mu x. So x minus mu x whole square divided by 2 sigma x square. Here basically let's just say sigma x square was 1. Here if I say sigma x square was 1, sigma x square was 1 and mu x was 0. So kind of you are getting the same expression. No? If I say mu x was 0, if I put mu x equals to 0, what I will be getting? E to the power minus x square divided by 2, sigma x square is 1. So this expression I will be getting. And 1 upon under root 2 pi, sigma x square is 1. So 1 upon under root 2 pi. But here there is a integration. This function is defined with respect to integration. But this is not defined with respect to integration. This is simply fx of x, 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. This is something should be there in your mind. Is that clear to you? Okay. So a lot of things I have written down here. So let me adjust it. Let me adjust in a good manner. Otherwise, this is not looking good. So this is the graph. This is the calculation that we have done. 1 upon under root 2 pi sigma x square, right? And area, total area I calculated, that is coming out to be 1 only. Now mean square value and variance. We already know everything, right? This will be the mean. Basically, how do I calculate the mean? Expectation of x would be equals to minus infinity to infinity. Here x goes from minus infinity to infinity, right? X is going from minus infinity to plus infinity. X into fx dot dx minus infinity to infinity x. What is your fx? 1 upon under root 2 pi sigma x square. So 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Now this integration will become very difficult, but when you solve this integration, answer would come out to be mu x. Basically this answer will come out. So that's why in the expression itself we write down in the manner that from expression only we can get to know what is my mean and what is my variance. So this is how we define our Gaussian random variable or our normal distribution. What will be given? X is a Gaussian random variable having mu x mean and sigma x square variance. If it is written like 2, 3, that means mean is 2 and variance is 3. So the way function is defined, from the function itself we can get to know that what is my mean. That is coming out to be mu x. It is not that easy to solve this particular integration, right? First you will have to put x minus mu x equals to t. Then you will convert it into t square divided by 2 sigma x square dot dt. In that manner you will convert, and then what you will do? You will put t square divided by 2 sigma x square equals to alpha. From there you will cancel out this particular thing and then you will get the answer. It will come out to be mu x only. You can do the integration when you study mathematics. At that time you can do the integration. Your answer will come out to be mu x. Okay. What do you think? What will be your mean square value? First, let's talk about the variance, or let's talk about the mean square value. So, what will be my mean square value? So, this integration I need to perform. Here it was x, now it is x square. So, it will become more tougher, right? It will be tougher to solve this integration. But again and again, you keep on writing the expression 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. Okay, so you again and again keep on writing it so that it becomes habitual for you. So what will be your answer? What do you think? What should be the answer? You know that what will be my variance? What do you think? What will be your variance? So variance is already I know that will be sigma x square. This will be my variance. This will be my variance. So when you solve this particular integration, the answer came out to be sigma x square plus mu x square. This is what the answer came out to be. And it is pretty obvious, no? Because you know that sigma x square should be equals to expectation of x square minus expectation of x whole square. So expectation of x square, which is known as mean square value, should come out to be sigma x square plus what is this? Mu x whole square. So from the expression itself, you will never have to solve the integration. From the expression itself, you will be able to see a lot of good things. Okay, so remembering the expression is very, very important. All good, all fine. So now we will solve some questions. This you already know. I am just asking, you need to find this particular thing. This I have already told you. X minus 2 you will put equals to t. What you will do? X minus 2 is equals to t. So dx would be equals to dt. So integration limit will go from minus infinity to infinity. e to the power minus t square dot dt, that will come out to be under root pi only. So basically just for shifting the graph, your area will not change. You just have shifted the graph, area will not change, right? Very simple question. What about this one? What do you think? What will be the answer of I? Think about it. Think about it. Take your time. Try thinking. Whatever you are able to think, it's fine. If you are not able to think, then also it is fine. Okay. What is the meaning of this exp? Exp means exponential to the power. Basically, exp means exponential to the power minus x minus 2 whole square divided by 4. So think about it, do something and try getting the answer of I. I will take a break and then I will come back and we will solve this question. Yeah, welcome back. So did you try this question? In the examination, if this question is coming in front of your screen, then you will say that, sir, integration is not that very easy, right? It is not that easy. It will take a lot of time. So integrating will not be the cup of my tea, but what I would do? I know something. This might be expectation of x square, right? This is something expectation of x square I will be getting because here there is x square. So what do you think what I will do? I remember this particular thing, that this is my standard PDF. This is my standard PDF. And can I relate? Yes. What I can do? If I put mu x equals to 2 and sigma x square also equals to 2, what I can get? 1 upon under root 4 pi e to the power minus x minus 2 whole square divided by 4. So this will be my fx of x. And one thing I know, that if I do expectation of x square, so that will come out to be, expectation of x square will be sigma x square plus mu x square. That means it will come out to be sigma x square. What is sigma x square? That is 2. And what is your mu x? Mu x is also 2 plus 4, that will come out to be 6. So this answer will be 6. So this 6 will be equals to what? 6 will be equals to minus infinity to infinity x square fx of x dot dx, right? So basically minus infinity to infinity x square. What is your fx of x? That is upon under root 4 pi e to the power minus x minus 2 whole square divided by 4 dot dx. This is your fx of x. X square is already there. What is fx of x? Fx of x is 1 upon under root 4 pi e to the power minus x minus 2 whole square divided by 4 dot dx, and that will come out to be equals to 6. What do you need? You need x square e to the power minus x minus 2 whole square divided by 4. Basically this under root 4 pi is creating the problem. So let's throw it here. So minus infinity to infinity x square e to the power minus x minus 2 whole square divided by 4 dot dx is coming out to be 6 into under root 4 pi. And that is the answer of I. So this is your I. 6 into under root 4 pi. So this is the answer. So I is 12 under root pi. Your integration I is coming out to be 12 under root pi. This is the answer. Did you understand? Very simple. What I would do, I know that integrating this will be a tougher task. X square is there, expectation of x square divided by 4, something is there. So I will try to relate with whatever that I know. I know my standard Gaussian random variable. This is the PDF, 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square. Then I know that if I need to compare it with this, that means mu x should be equals to 2 and sigma x square should be equals to 2. Right? So from here I made my standard PDF. Now expectation of x square is given as sigma x square plus mu x whole square plus mu x whole square. So sigma x square I already know, mu x whole square I already know. So expectation of x square should come out to be equals to 6, and 6 is equals to minus infinity to infinity x square fx of x dot dx. So x square, what is my fx of x? This is my fx of x dot dx. So this particular integration I needed to calculate. So from here I got my answer. Well and good. Very simple. You just need to think that if I don't know the integration, then some trick I need to play, and that trick I have played here. This one. Will you play any trick here? No. No trick, nothing. This integration is not tough, right? If this question is coming, is it tough? No. What you will do? X square equals to t. So all these things you can do with respect to mathematics as well, no? So every time it's not that you need to use different brain. Simple mathematics can also work, right? And what about the limit? If x is 0, then t is also 0. If x is infinity, then t is infinity. So what is your I? From 0 to infinity, x dx would be put as dt by 2, and t is, so x square is t. So e to the power minus t square, x dx would be dt by 2. So 1 by 2, 0 to infinity, e to the power minus t dot dt. So answer will be 1 by 2. So answer of I is 1 by 2. So needlessly don't start comparing anything, okay? So needlessly we don't need to put any pressure on our brain that this thing should happen, that thing should happen. Simply you need to integrate here. Simple integration is very easy here, right? Job done, job done. What about this one? This is your standard PDF. You need to find the value of k. So again, do you think I need to compare or anything? No. What I need, if I need to find the value of k, what I will do? Minus infinity to infinity. This is the process that I always follow. Minus infinity to infinity, fx of x dot dx should be equals to 1. That means minus infinity to infinity, k e to the power minus x square by 2 dot dx should be equals to 1. So k is a constant. E to the power minus x square dot dx, that would throw under root pi. If there is downward, there is 2. So under root 2 pi, that is equals to 1. So what is the value of k? 1 by under root 2 pi. There you go. This is the answer. Or you could have compared as well. Like how would you compare? That fx of x is equals to 1 upon, this is what I remember, 1 upon under root 2 pi sigma x square exponential x minus mu x whole square divided by 2 sigma x square. So you know that sigma x square, if I compare from here, then what I can see, mu x I need to put equals to 0 and sigma x square I need to put equals to 1. So from here, what is the value of k is coming out to be? So k is coming out to be 1 by under root 2 pi sigma x square, with sigma x square is 1. So 1 by under root 2 pi. So value of k is 1 by under root 2 pi. There you go. Okay. So value of k is 1 by under root 2 pi. Very simple, but you don't need to compare all these, comparing and all these kind of things is not necessary. You directly can think that from minus infinity to infinity, basically for the whole area under the curve should be equals to 1. And I already know what will be the area under the curve for this one. Because I told you to remember e to the power minus x square dot dx would throw under root pi. So e to the power minus x square by 2 will throw what? Under root pi, whatever that you see downward, that should come in the under root. So k into under root 2 pi should be equals to 1. So value of k will be 1 upon under root 2 pi. So that's why in the last lecture I told you to remember one thing. This is very, very important. This will help you a lot. So always remember this. What is the answer? Under root pi. That's it. Always remember this. Just if you remember this particular thing, a lot of questions will be solved. Okay? Right? What about this one? Again, will you compare on anything? No. Always, very rarely, when you will compare, mostly when you see x square here, x square, and then in the exponential as well there is x square, then yes, comparison should come, because like solving this particular integration is very difficult. Here already there is x square, along with that here also you are having x square, basically x minus 2 whole square is there, no? So already you are getting x to the power 2, here also you are getting x to the power 2. But what if here you are getting x to the power 2, but here you are getting x to the power 1 only? So you know that if I put x square equals to t, then my job is done. But if same power here and same power here, then you need to think, right? And how will you think? That you already know. You need to compare it with the standard PDF. Do you think I need to compare here? No. What I can do? E to the power minus x square dot dx. I already remember the standard results. So what I will do? X minus 2 equals to t. So dx equals to dt. What about the limit? If x is equals to t, then t would be 0. If x goes to infinity, t would go to infinity. So limit of t is going from 0 to infinity. E to the power minus, in place of x minus 2 you are putting t square by 30 dot dt. In place of dx you will be putting dt. What will be the answer of this particular thing? You know that if only e to the power minus t square was there, then answer would be under root pi. But divided by 30 is there, so under root 30 would come inside. But if the limit was from minus infinity to infinity, but the limit is from 0 to infinity, that means area have been half. So this is the answer. Okay, under root 30 pi divided by 2, divided by complete 2, not in the under root. If it was from minus infinity to infinity, then the answer would have been under root 30 pi, but it is from 0 to infinity, that's why divided by 2. So very simple. If you compare, it will be a bit difficult. Okay, it will not be difficult, it will just take time. Like let's try solving it with respect to the comparison. So you can solve with respect to comparison as well, but forget about the comparison. This is how I will be solving it. All good, all fine. So yeah, this is the end of question. Now there is some important result. Now x is your Gaussian random variable having mean of mu x and variance of sigma x square. Probability of random variable x taking value greater than mu x. That means what you will be doing, basically what is your fx of x? Fx of x is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, right? So if I need to find probability of random variable x taking value greater than mu x, that means I need to find this area. This area you need to find. Just let me know what should be the answer of this area. The graph is symmetric about mu x, right? The graph is symmetric about mu x. You know one thing, that from minus infinity to infinity, fx of x dot dx, from minus infinity to infinity, the whole area is 1 and it is symmetric about mu x. That means before mu x and after mu x the area would be same. The graph is symmetric about mu x. That means before mu x and after mu x the area should be same. So from mu x to infinity, what should be the area? From mu x to infinity, 1 by under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square dot dx. What should be the answer? 1 by 2. So in place of x minus mu, you can put equals to t. What I will do, in place of x minus mu x, I will put t. The limit will go from 0 to infinity. Similar this process we need to do. X minus mu x you put equals to t, e to the power minus t square divided by 2 sigma x square dot dt. Limit will go from 0 to infinity, right? So e to the power minus t square 2 sigma x square, what it will throw? 2 pi sigma x square. So this and this will get cancelled out, and since the limit is going from 0 to infinity, so answer will be half. So you just need to know one thing, that your graph will be symmetric about mu x. Are you able to understand this point? So in case of normal distribution, if you calculate the probability from mu x to infinity, that means if your random variable x is taking value greater than equals to mu x, if you calculate this, that would be equals to from minus infinity to mu x fx of x dot dx, and that would be equals to half. Mu x to infinity minus infinity to mu x, half, and total area would be 1. Is that clear to you or not? So here this is something that you need to remember. So can I write it down as probability of random variable x taking value lesser than equals to mu x? Probability of random variable x taking value greater than equals to mu x and taking value lesser than equals to mu x, both will be same and both will be equals to half, because the graph is symmetric about mu x. Is that okay for you? Okay, let's see more results. What you need to find? You need to find the probability of random variable x taking value greater than a. What is your x again? What is your random variable x? Again Gaussian random variable having mean mu x and variance sigma x square. That means your fx of x is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, right? You need to find probability of random variable x taking value greater than a. This is what you need to find. That means what you need to find? From a to infinity, 1 upon under root 2 pi sigma x square e to the power x minus mu x whole square divided by 2 sigma x square dot dx. Try comparing it with something that you already know. What we studied in the last lecture, in the ending of last lecture, what we studied? Q function. So try comparing it with Q function, whatever that you already know. What is your Q function? My Q function is 1 upon under root 2 pi, x goes from 0 to infinity, e to the power minus x square by 2 dot dx. This integration I need to compare with Q function. Will you be able to relate? What you need to do? You need to, and here you need to put t, right? Again I do the same mistake. Here I need to put t square by 2 dot dt. So what do you think what I should do? X minus mu x divided by sigma x. X minus mu x divided by sigma x should be equals to t. Say yes or no. If I put x minus mu x divided by sigma x equals to t, what I will be getting? Dx sigma x goes here dot dt, right? This is sigma x. Basically simple thing is there, no? X minus mu x sigma x dot t. So differentiation of x will be dx. This is a constant. Differentiation of mu x will be 0. Sigma x is also a constant, but this is in the multiplication. So sigma x dot dt. So dx is equals to sigma x is a constant in the multiplication dot dt, right? And what about the limit? What about the limit? If x is equals to a, then t would be equals to a minus mu x by sigma. And if x is equals to infinity, then t would be equals to infinity. So probability of random variable x taking value greater than a would be equals to 1 upon under root 2 pi sigma x square e to the power minus x minus mu x by sigma, so that would be x minus mu x by sigma is t, so t square by 2, so e to the power minus t square by 2, x minus mu x whole square divided by sigma x square, so t square by 2 dot dt. Are you able to relate? Right? And in place of from where to where the limit is going? Limit is going from a minus mu x by sigma x to infinity. A minus mu x to sigma x to infinity. A minus mu x divided by sigma x to infinity. So limit is going from a minus mu x divided by sigma x to infinity, but here I did a mistake. In place of dx you need to put sigma x into dt. Just very simple derivation. In place of dx what I am putting? Sigma x into dt, right? So here this was 1 upon under root 2 pi sigma x square. So if I take out the under root, so this sigma x and sigma x can get cancelled out. So what you are getting? Probability of x greater than a is coming out to be from a minus mu x divided by sigma x to infinity 1 by under root 2 pi e to the power minus t square by 2 dot dt. This thing and this thing. Are you able to relate? Yes, you are able to relate. How will you relate? Let's just take it upward. I think I need to add a page only. Okay, I am already having a page. So let's just copy this thing. I hope you are able to understand the derivation. Very simple, very straightforward, nothing else. Just started with this one. We needed to compare this thing with q of x. So that's why I am doing all this thing. That x minus mu x divided by sigma x I put equals to t, so that I can get e to the power minus t square by 2, so that I can compare. From here limit and everything got changed, so I wrote down the changes. So here sigma x was there, sigma x is getting cancelled out. So now somewhere I am able to compare. So this is my probability of x greater than a, right? And this is your q of x. So what do you think? What will be your q of a minus mu x divided by sigma x. What do you think? What will be the answer of this one? In place of x, what you need to put? A minus mu x divided by sigma x. So 1 upon under root 2 pi. In place of x, you need to put a minus mu x divided by sigma x. Going from a minus mu x divided by sigma x to infinity. A to the power minus t square by 2 dot dt. This thing and this thing both are same. So what did you understand? Probability of random variable x taking value greater than a is coming out to be q into this a, whatever a is written, a minus mu x divided by sigma x. So basically a random variable will be given, a random variable x will be given having normal distribution with the mean mu x and variance sigma x square. You would know how to draw its fx of x. You will draw its fx of x in this manner. That sir, I know how to draw its fx of x. That would be like this. Okay, so this point is 1 by under root 2 pi sigma x square. This point is mu x. This point is mu x. All good. This point is mu x and this is the amplitude. This is the random variable x taking value. Now what I am asking? I am asking the probability of random variable x taking value greater than a. Let's just say this is a. Let's just say this is a. X equals to a. So what I am asking? This is your x equals to a. I am asking this probability. Probability of random variable x taking value greater than a. So that would be equals to a to infinity fx of x dot dx. And that would be equivalent to what? Q greater than a, greater than a. So q greater than a. Q of a minus, you would already be knowing that mu x value, you would already be knowing that sigma x value as well. So that would be the answer. Is this conclusion clear to you? Say yes or no. So a normal distribution is given having mean of mu x and variance of sigma x square. This is the graph I can make. They are asking probability of x greater than a. That would be equals to q of a minus mu x divided by sigma x. Should be there in your mind. You already know what is q function, right? So we are comparing and everything we got to know, but now this conclusion should be clear to you. Okay, so this is what we are writing down. Probability of, this is my mu x, this is my mu x. The center will be mu x. Where you are having the maximum amplitude, the center would be mu x. This would be your mu x. What they are asking? Probability of a random variable x taking value greater than a. So that would be come out to be q into a minus mu x divided by sigma x. Gaussian random variable x such that it is normally distributed with mu x mean and sigma x square variance. So what do you think? What will be the probability of a random variable x taking value lesser than equals to? What will be the probability of random variable x taking value lesser than equals to a? That means this particular probability they are asking now. Which probability they are asking? Which probability they are asking now? This particular probability they are asking now. So that will be equivalent to 1 minus x greater than a. Because you know that probability of x greater than a plus probability of x less than a is equals to 1. So x less than a would be equals to 1 minus probability of x greater than a. 1 minus probability of x greater than a. So that will be equivalent to 1 minus q a minus mu x divided by sigma x. There you go. Say yes or no. Right? So what do you think, what will be your CDF of a Gaussian random variable? CDF of Gaussian random variable normally distributed with the mean mu x and variance sigma x square. What do you think, what will be the CDF? So how the CDF is defined? CDF is defined as fx of x. It shows that probability of random variable x taking value lesser than equals to x. But for Gaussian random variable, what do we remember? We remember probability of random variable x taking value greater than equals to small x. This is what we remember. We don't remember lesser than small x. What we remember this one. We usually remember this particular thing. This answer we remember. So I can convert it 1 minus x greater than equals to 1 minus x greater than equals to x or x greater than x. This is how I can convert it, and I know that what will be the answer of this one. Q of x minus mu x divided by sigma x. Right? X greater than a was a minus mu x divided by sigma x. So x greater than small x would be x minus mu x divided by sigma x. So this is your fx of x. Do you remember one thing? Q of x plus q of minus x is equals to 1. So basically q of x would be equals to 1 minus q of minus x. So basically if I am writing down 1 minus q of something, so can this be written as q of mu x minus x divided by sigma x? Do you agree to this point? Because I know that, let's just say this was t. So q of t plus q of minus t would be equals to 1. If this was t, so this would have been minus t. So q of t plus q of minus t would have been equals to 1. So 1 minus q of x minus mu x divided by sigma x is written. So this is how I can write it down. So one of the thing could be mentioned in the options. Either this could be mentioned, either this expression can be mentioned, or this expression can also be mentioned. So you need to remember this particular property, that q of x plus q of minus x is equals to 1. So from here you can write it down in this manner. Is that okay for you or not? Well and good, very simple. So only thing you need to remember is probability of random variable x taking value greater than equals to a. That would be q of a minus mu x divided by sigma x. So if you need to find out fx of x, then you can follow this process and you will get the answer. What does fx of x says? X should be having the value lesser than equals to small x. Then 1 minus probability of x taking value greater than equals to small x. If I know the answer of this one, then I can write it down 1 minus q small x minus mu x divided by sigma x. So this is the answer you are getting. Well and good. Okay, so this is the graph of fx of x. Just let me know what will be the value of fx of mu x. Fx of mu x. So 1 minus, in place of mu x, in place of x you need to put mu x. In place of x you need to put mu x. So 1 minus q, let's do it on the next page. So your fx of x was 1 minus q x minus mu x divided by sigma x. You need to find the value of fx of mu x. That would be equals to 1 minus mu x minus mu x divided by sigma x. So that would be equals to 1 minus q of 0. What is the value of q of 0? That is 1 by 2. From the last lecture we remember. So answer would be 0.5. So at mu x the value will be 0.5. And which is pretty obvious as well, because you know that what would this represent? This would represent the probability of random variable x taking value lesser than equals to mu x, right? And here only we told that probability of random variable x taking value lesser than equals to mu x, or probability of a random variable x taking value greater than equals to mu x is equals to 1 by 2. So this is your 1 by 2 only. So by any method you can tell this value will be 1 by 2. And what will be the value of fx of infinity? So here if you put x equals to infinity, here if you put x equals to infinity, so q of infinity is 0. Q of infinity is 0. So 1 minus 0 would be 1. And what will be q of minus infinity? Q of minus infinity will be 1. So 1 minus 1 will be 0. And you know the property of CDF. CDF will go from 0 to 1 only. So this is your fx of x. Is that okay for you? Okay. So now there is a question that random variable x is given having mean and variance of this. What you need to find? Probability of a random variable x taking value between a to b, then a to b, a to b and a to b like this. Okay. So do this question on your own. I will take a break and then I will come back. Do this one. Random variable x is given having mu x mean and variance sigma x square. You need to find the answer of all these four. So do it on your own. I will take a break and then I will come back. Yeah, welcome back. So did you try this question? So first thing is that x is a continuous random variable, no? Right? X is a continuous random variable. So for continuous random variable, all these probabilities will be same only, no? Right? So I don't need to find them separately. This is the first conclusion that I can make. Because if it is a continuous random variable, that means probability at a point will be 0. That means all these probability I don't need to find separately. All these will be equal. So here only I am putting the equal sign. All these will be equal. So simply what I am doing, I can find this probability, or I can find this probability, or I can find this probability, or I can find this probability. All of them will be the same only. Now let's find this probability with respect to the diagram. So mostly I will prefer making the diagram. When it comes to normal distribution, I will try making the diagram. So I am gonna find out this probability with respect to the diagram. So what they are saying, greater than A but less than B. Let's just say this is your A and this is your B. Greater than A but less than B. That means this probability they are talking about. Right? Greater than A, less than B. So can I write it down in this manner? It is your probability of x greater than A minus x greater than B. X greater than A means A to infinity. X greater than B means B to infinity. So from A to infinity you are subtracting B to infinity. That means you are talking about A to B. Now what is probability of x greater than A? Q of A minus mu x upon sigma x. And what is x greater than B? Q of B minus mu x upon sigma x. There you go. This is the answer. Very simple. So no need to mug up. You can derive it any day, right? Just make the diagram, you will understand everything. Here I could have solved it with respect to CDF as well. Like if I have solved it with respect to CDF, what I would have done? Fx of B minus Fx of A. But I know that I usually remember this answer, no? I don't remember this answer. I usually remember this answer. So what I would have done? Better I would have made the diagram, and I know that I remember the answer for greater than, not for the lesser one. For lesser one I can make the answer, right? Just the way I made here. For lesser one I can make the answer, but for the greater one I remember the answer. That is Q of A minus mu x upon sigma x. So in this manner I will solve it. With respect to this as well I could have solved it. What I would have written? 1 minus Q of B minus mu x upon sigma x, then 1 minus Q of A minus mu x upon sigma x. So you can see that 1 and 1 will get cancelled and you will get the same answer. Q of A minus mu x upon sigma x minus Q of B minus mu x upon sigma x. But usually what we will do is that we will solve the problem of Gaussian random variable with respect to the diagram. Okay. So diagram is much easier than all these kind of things. So always I will try making the diagram rather than going into complex expressions. And with respect to diagram only I remember one particular answer, which is this one. That probability of x greater than A would be equals to Q of A minus mu x upon sigma x. That's it. Right. Now let's write down the conclusion. So let's just say this is the midpoint. Right? Normal distribution, this is the midpoint. At midpoint what will be the magnitude? 1 upon under root 2 pi sigma x square. 2 pi sigma x square. Right? And if someone asks you what is the PDF, so your PDF is 1 upon under root 2 pi sigma x square e to the power minus x minus mu x whole square upon 2 sigma x square. Right? Probability of x greater than B, that means this is what I am talking about. So it would be equals to Q of B minus mu x upon sigma x, b minus mu x upon sigma x, right? X less than a if I am talking about, this probability I am talking about. That means what I need to do, 1 minus probability of x greater than a, because I remember the answer for greater than a. So what will be the answer? 1 minus q a minus mu x upon sigma x. And if I am talking about the probability between a to b, what does that mean? That I am saying that x is greater than a, but x is less than b. Sorry, x is greater than a minus x is greater than b, right? X is greater than a minus x is greater than b. That means you will get the probability between a to b. So your answer would be q of a minus mu x upon sigma x minus q of b minus mu x upon sigma x. And all these combined from minus infinity to infinity, everything would be what? Everything would be equals to 1. And if I ask you x taking value greater than mu x, or if I ask you x taking value less than mu x, both will be equal and equal to half. Now there are other standard distribution as well. We have studied about two distribution. Which two distribution we have studied about? We have studied about uniform and Gaussian. Gaussian you can say, or you can call it normal as well. Both names I need to remember. So these two distribution we have studied everything. Okay. Now there is something called exponential distribution, Rayleigh distribution, gamma, Laplacian, chi-square, Cauchy, triangular, Bernoulli, binomial Poisson. So they are also important, but they are with respect to discrete random variable, and you will study it in engineering mathematics. Okay, so don't worry about that. Very simple, like basic probability in class 12th as well you have studied it. Do you remember that problem which we used to solve with respect to the probability, with respect to P and C, right? There was some Poisson, there was something called binomial distribution. There was something called Poisson distribution as well. So those you will study in mathematics. Don't worry about that. Okay. So in communication system, with respect to communication system, only two kind of distributions are important that we have studied. Two kind of standard distribution, uniform and normal, and we have studied that in a very good manner. Now from all these you don't need to remember any answer. Like here you need to remember answers. What you need to remember? For uniform distribution you need to remember the expected value a plus b by 2. You need to remember variance as well, b minus a square divided by 12. In Gaussian as well you need to remember certain things, that mean will be mu x, sigma x square. You need to remember the expression as well. So all these things you need to remember, but for all these kind of things nothing you need to remember. You will simply solve the question. So we will frame the question based on all these distributions now, like based on exponential, based on Laplacian, on all these distribution. If some question is coming, you will be able to solve it. In the first, second and third lecture, how did we study? Like there was some fx of x was given, you need to find the value of k, you need to find the probability greater than something. Like there was different kind of expression, no? Like as far as I remember, there was this expression, right? There was something kind of this expression was there. This kind of expression was there, right? Where x was going from minus infinity to infinity. This was your fx of x. And there I asked you probability of x greater than 2, all these kind of things. So if these kind of things are coming, then simply whatever the method is there, you draw the PDF, x is greater than 2, that means you go from 2 to infinity, fx of x dot dx. So there nothing we are going to remember. Are you able to understand this point? So any general question could be coming. With respect to that general question, we will be able to solve the problem. Well and good. Now let's solve this question. So what they are saying, x is a triangular distribution going from minus 1 to 4. X will be taking value minus 1 to 4, and you are having the maximum amplitude at x equals to 2. If I say triangular distribution going from A to B, in between C would come. What does that mean? That means A to B, in between C would come. That means you are having maximum amplitude at C. This is not the midpoint. This is the maximum amplitude point. You will be having the maximum amplitude at C. So it will be a triangular distribution. Here, sorry guys, this will be written x as triangular distribution. So A to B at C you will be having the maximum amplitude. All okay for you? Okay. And they will actually define it. They will not write down directly like this, because this is not that much standard. Uniform and Gaussian are very standard. In digital communication, only these two will come. In the examination as well, these two only will come. Everywhere, these two will keep on coming. But from all these distribution as well, some questions can be framed, and questions will be framed in this manner. Are you able to understand my point? Even if they define like this, they will tell you the definition. What is the definition? The definition is that between -1 to 2 there is different kind of curve. Between 2 to 4 there is different kind of curve. Right? The equation of this line will be different. The equation of this line will be different. Are you able to understand this point? Now you need to find the value of k, and then you need to find the mean of random variable x. So how will you find the value of k? So you know that for finding the value of k, what I know, minus infinity to infinity fx of x dot dx, that would be equals to 1. So half into base into height is k, is equals to 1. So k is coming out to be 2 by 5. So what is the value of k? 2 by 5. So value of k is actually coming out to be 2 by 5. Just you need to calculate the area. Area is half into base into height, that is equals to 1. Right? So the k is coming out to be 2 by 5. Right? Now what you need to find? You need to find the mean of a random variable x. So mean of random variable x, that would be from minus infinity to infinity x fx of x dot dx. But fx of x is non-zero between -1 to 4 only. So you can change it in this manner, -1 to 4 x fx of x dot dx. Now let's define fx of x. What we are doing? We are defining fx of x. So what you can see, that between -1 to 2, if your x is between -1 to 2, there is some different equation. What will be the equation of this line? Can you write it down? Surely you can write down. The equation of this line will be y equals to mx plus c. What is the slope? 2 by 5 divided by 3. So slope will be 2 by 15. What is the x-axis? X plus c. That means at x equals to -1, you are getting the value 0. So this would be plus 2 by 15. So this is the definition. Are you able to understand? Right? This much thing you are able to understand or not? Just I am writing down the equation between -1 to 2. So the equation is 2 by 15 x plus 2 by 15. This is the definition between -1 to 2. And when your x is between 2 to 4, what is the definition? So y equals to, what is the slope? Slope will be 2 by 5 divided by 2. So -1 by 5. Slope is negative, right? So y-axis, length of y-axis divided by length of x-axis. So 2 by 5 divided by 2, but the slope is negative. So -1 by 5 x plus c. So at x equals to 4, you are getting the value 0. What does that mean? That c has to be 4 by 5. If I put x equals to 4 here, I am getting the value 0. So that means for 2 to 4, the definition is minus x by 5 plus 4 by 5. So this is the definition of fx of x, and otherwise it is 0. Otherwise it is 0. 0 otherwise. So this is the definition of fx of x. So now you need to break this integration. No? We have to break this integration between -1 to 4 x into, how will you break it? Between -1 to 2 there is different definition. Between -1 to 2 there is different definition. That definition is 2x plus 2 divided by 15 dot dx, and from 2 to 4 there is different definition, minus x by 5 plus 4 by 5 dot dx, and then you will get some answer. So you will solve this integration. The answer would come out to be this plus this divided by 3. What the answer will come? -1 plus 2 plus 4 divided by 3. You can solve it, you will get this answer only. Answer will come out to be 5 by 3. Solve this integration. I gave you the complete definition. First thing is that we found the value of k. Then we saw that what is the slope here? 2 by 5 divided by 3. So 2 by 15 is the slope. From there we find out this value 2x by 15 plus 2 by 15 between -1 to 2, and then the definition is changing from 2 to 4. So there as well we find out the equation. So in both of the cases we are just finding out the equation. Finding the equation is not a tough task. What is the slope here? -1 by 5 plus 4 by 5 would come, because at 4 this will throw the value 0, and at 2 this will throw the value 2 by 5, which is coming out to be here, and otherwise it is 0. So now the integration limit will be broken between -1 to 2 and then 2 to 4. So x into fx of x, x into fx of x dot dx, and when you solve this integration, this answer would come a plus b plus c divided by 3. Answer would be 5 by 3. So only for this triangular distribution you will remember the answer. What you will remember? If your triangular distribution is like this, a, b, c, going from a to c, maximum amplitude at b, then the mean of random variable x would be a plus b plus c divided by 3. Remember it. Okay. Who knows, it may be asked. If you are able to remember it, then it is good. Otherwise, you will have to solve this integration and you will get the answer. Both of the things are possible. Now, someone will say, sir, how to calculate the variance? So, in the similar manner, the way I calculated e of x, can you calculate e of x square? Yes. So, just this will happen. So, in the similar manner, you will calculate e of x square as well. And then e of x square minus e of x, basically, if I need to find out sigma of x square. So, e of x square minus e of x whole square. So, how will you calculate this thing? That you know. In place of x, you need to put x square. That's it. In place of x, you need to put x square. And then you need to solve the integration, you will get some answer. How will you get e of x? A plus b plus c divided by 3. And then do the square. Then this value will come. Calculation will be very complex and there is no standard result as well. So, you don't need to remember any result. So, mostly if they are giving you this kind of triangular distribution, then they will ask you the value of mean only. So, how will you calculate the value of mean? Mean will be simply a plus b plus c divided by 3. There you go. Or they can ask you the probability. Probability, what they are asking? Probability such that x is going from 0 to 2. X is going from 0 to 2. What does that mean? X goes from 0 to 2. Fx of x dot dx. Right? Between 0 to 2 is the definition getting changed? No. Between 0 to 2, what is the definition? 2x by 15. So 2 by 15 I can take outside. Between 0 to 2, what is the definition? 2 by 15 into x plus 1 dot dx. 2 by 15 into x plus 1 dot dx between 0 to 2. Between 0 to 2. So what you will be getting? 2 by 15 x square by 2 plus x from 0 to 2. 2 by 15, 2 plus 2, 8 by 15. This is the answer. Very simple thing, very straightforward. Right? Or what you could have done, you just find out the value of this one and then you could have calculated the area. This probability I am asking, no. So basically that will be equal to the area of this one. So if you know the equation, then you know that this value will be 2 by 15. Why is that so? Because if you put x equals to 0 here, this value will be 2 by 15. So what will be the answer here? Half into addition of parallel side, that is 2 by 15 plus 2 by 5. 2 by 15 plus 2 by 5. 2 by 15 plus 2 by 5. Into the height. Height is 2. So what is the answer you will be getting? 3, 6, 8 by 15 only. So what is the answer you are getting? 8 by 15. So here also 8 by 15, or by simply integration as well you could get the answer 8 by 15. So nothing you need to remember, no standard result you need to remember, you just need to remember the mean, that would be a plus b plus c divided by 3. Okay for you? And what if they are symmetric about origin? So do you remember the results for this one? Yes. Sir, if my uniform distribution, here your random variable x is uniformly distributed between minus alpha to alpha, and here your random variable x is triangularly distributed between minus alpha to alpha with maximum amplitude being at 0. Minus alpha to alpha, maximum amplitude being at 0. Right? So what would be the mean? Do you remember? A plus b divided by 2. A plus b divided by 2. Mean was 0. What was the mean square value? Mean square value was, what was the mean square value? Sir, this width 2 alpha square divided by 12. So alpha square by 3. And what was the variance? The same thing, right? Actually, this was not the mean square value, this was actually the variance. Really sorry guys. Width divided by this, I should not write down like this. Actually, we remember the formula for variance. Formula for variance is width whole square divided by 12. So answer will be alpha square by 3. Now here, since your mean is 0, that's why your mean square value and variance would be the same. Because if mean is 0, then mean square value and variance would be the same. So alpha square by 3, alpha square by 3. Here what do you think what will be the mean? Minus alpha plus 0 plus alpha divided by 3, that would be equals to 0. Now sir, for variance we don't remember any answer. So what you will do, you will think that if it was uniform, then what would be the answer? Alpha square by 3. Just you need to make it half. Alpha square by 6. Alpha square by 6. Are you able to understand this point? So what all things I am asking you to remember? One thing is that what will be the mean of triangular distribution? That would be a plus b plus c divided by 3. And if it is symmetric, then what will be its mean square value or what will be its variance? That will be alpha square by 6. This is what I am asking you to remember. Here you will be getting confused about 6, that sir what value should come? Then what should come into your mind? That sir, if it was uniform, then what would be the answer? 2 alpha square divided by 12. So answer would have been alpha square divided by 3. So now just the half answer would be there, alpha square by 6, alpha square by 6. So answer would have been alpha square by 6. So this is how you need to remember. So this slide, will you be able to remember? Mean will be midpoint 0, 0. Forget about mean square value. For variance, I remember the formula, width square divided by 12. Width square divided by 12. Here I am getting alpha square by 3 answer. Here just the half of the answer would be there, alpha square by 6. And since the mean is 0, so mean square value and variance would be the same. There you go. All good? All fine? Let's go to this question. You need to find the mean. This particular distribution is given. Fx of x is x by 3 e to the power minus x square by 6 for x greater than 0. You need to find the mean. So what you will do? Sir, I need to find the expected value of x. That means minus infinity to infinity x fx of x dot dx. But I know that x is going from 0 to infinity only. So x goes from 0 to infinity x into x by 3 e to the power minus x square by 6 dot dx. So 0 to infinity x square by 3 e to the power minus x square by 6 dot dx. Now this particular thing you need to calculate. How will you calculate? What do you think? Can you relate it with something? Can you relate it with something? Right? Surely you can remember. What we remember? This is my target. I need to solve this integration. I know that x square is there, it will be difficult. So what we remember? We remember that here since x is already given, no, fx of x. So that's why I am saying fy of y. Okay. So that would be equals to 1 upon under root 2 pi sigma y square e to the power y minus mu y square upon 2 sigma x square. So directly I can see that mu y should be equals to 0, right? And sigma x square should be equals to 3, right? So what you are getting? Fy of y is coming out to be 1 by under root 6 pi e to the power minus y square by 6. Y square by 6, right? Now you know that here what I have put, mu y is equals to 0 and sigma y square here y, right? Sigma y square is equals to 3. Sigma y square is equals to 3. Now you know that expectation of y square would be equals to minus infinity to infinity, since it goes from minus infinity to infinity, y square into fy of y dot dy, and that would be equivalent to what? Sigma y square plus mu y square. So here what you can see, minus infinity to infinity y square into 1 by under root 6 pi a to the power minus y square by 6 dot dy, that would be equals to sigma y square is 3 plus this would be equals to 0. So under root 6 pi goes here, what you are getting? Minus infinity to infinity y square e to the power minus y square by 6 dot dy is coming out to be 3 into under root 6 pi. Say yes or no? 3 into under root 6 pi. But what do you remember? What do you want? Here you want x square by 3 e to the power minus x square by 6 dot dx. This is what you want. So let's not what you want, x square by 3 e to the power minus x square by 6 dot dx. This is what I want, right? So what do I know? That this is your even graph, right? This graph is even. This particular graph is even. So what I can break down? 0 to infinity y square e to the power minus y square by 6 dot dy would be equals to this particular thing, 3 into under root 6 pi. And from here what I can get? 0 to infinity. From here to here I am going. So in place of y square, in place of y what I am putting x. Can I do it? Yes. X square e to the power minus x square by 6 dot dx would be equals to 3 by 2 under root 6 pi. What I need to calculate? I need to calculate this particular thing. So x square e to the power minus x square by 6 dot dx, that is coming out to be 3 by 2 under root 6 pi. 3 by 2 into under root 6 pi divided by 3. So what will be the answer? 3 and 3 get cancelled. Under root 6 divided by 2. So answer would be under root 3 pi by 2. Basically this 2 goes inside. So what you get? Under root 3 pi by 2. So this is the answer you are getting. Very simple, very straightforward. Just the calculation is there. So I used my brain. Basically my target became that you need to solve this particular integration. There I used my brain that how would I solve this integration. So then I saw that this is 3 by 2 under root 6 pi that I got from here, and then I put the value here. So 1 by 3 is there, 3 get cancelled. So 4 goes inside. So under root 3 by 2, this is the answer I am getting. All good, all fine. Solve this question on your own. Let me take a break. Why I am taking the break frequently? Because match is going on. Okay, India versus England. So I need to see the score. So you solve this integration, very simple, and then we will come back. Yeah, welcome back guys. Actually India lost the game just by 22 runs. Only by 22 runs we lost the game. That too test match. That too in Lords. Those who watch cricket, they would know that this is very heartbreaking. But forget about it. Let's solve this question. So what do I know? That I can solve the problem which are something like this. X square fx of x dot dx. But here x plus 3 is written. So what I will do? I will put x plus 3 as t. Right? So dx would be equals to dt. Basically I need to make a single variable square. So that's why I am doing x plus 3 equals to t. So dx will be equals to dt, and limit will go from minus infinity to infinity only. Because if x is minus infinity, then t is also minus infinity. If x is plus infinity, then t is also plus infinity. From minus infinity to infinity, t square e to the power minus 3t square dot dt. Right? And now the comparison game will start. Right? How will you compare? Fx of x, what do you know? 1 by under root 2 pi sigma x square e to the power minus x minus mu x whole square divided by 2 sigma x square, right? So here directly I can see that mu x is coming out to be 0, but 2 sigma x square is coming out to be 1 by 3. 2 sigma x square is coming out to be 1 by 3. So sigma x square is coming out to be 1 by 6. So what is your fx of x now? Did you understand? 2 sigma x square is coming out to be 1 by 3, because if it is 1 by 3, then your job is done, right? So what is your fx of x now? So that would be 1 by under root 2 pi by 6. So under root pi by 3. So under root 3 by pi e to the power minus 3x square. Say yes or no? Right? So under root 3 by pi, this will be the answer. Very simple. Well and good. Now this is your fx of x. Now what do you know? That from minus infinity to infinity, x square into under root 3 by pi e to the power minus 3x square dot dx would be equals to what? Would be equals to sigma x square plus mu x square. That means it would be equals to 1 by 6 plus 0. So x square e to the power minus 3x square dot dx, that would come out to be equals to 1 by 6 into under root pi by 3. There you go. This is the answer. Right? Very simple. This is the answer. How did I get this answer? This goes here. So what you are getting? 1 by 6 into under root pi by 3. 1 by 6 into under root pi by 3. And this is what you need to find, x square e to the power minus 3t square dot dt. Sorry, t square minus 3t square dot dt. So here what you are doing, x square e to the power minus 3x square dot dx, which is same. In place of x, if you put t, you are getting the same answer. 1 by 6 under root pi by 3. 1 by 6 under root pi by 3. So what you are getting, 1 by 6 into under root pi by 3. So this is the answer we are getting. This is the value of I you are getting. Okay, very simple. Let's solve this question. In this question you will get one concept as well. Okay, we will solve the problem, along with that we will understand the concept as well. So what is given? This fx of x is given. This is a valid PDF. This is surely a valid PDF. If they have given, that means surely it is a valid PDF. You need to find, so what is given? Probability of x greater than equals to 1 is given, that is 0.16. You need to find all these things. So let's try getting some information from here. This I understood that surely it is Gaussian random variable. So what do I know? Fx of x in this manner I know. Under root 2 pi sigma x square. I will keep on writing this expression so that it is there in your mind. Okay, so you should also keep on writing down this expression so that you don't ever forget it. So from here what you can see, that your mu x is equals to 0.5, sigma x square is equals to 1 by 2. Mu x is equals to 0.5, sigma x square is equals to 1 by 2, right? So can you draw the diagram for this one? Mu x is 0.5, sigma x square is 1 by 2. So mu x is 0.5 here, sigma x square I don't show. Now what they are saying, probability of x greater than 1 is equals to 0.16. Where will be x equals to 1? X equals to 1 will be somewhere here. This is your x equals to 1. So this probability they have shown, that is 0.16. Next what they are asking, probability between 0.5 to 1. Probability between 0.5 to 1. So can you let me know what will be the probability between 0.5 to 1? You know that this total probability from here to here, this total probability is 1 by 2 minus 0.6. That would be the answer, right? So answer would be 0.34. This is the answer of first one. Did you understand this point? This is the mean, no? This is the mean. So from here to till the end, you know that probability of x greater than 0.5 will be equals to what? 1 by 2. And probability of x less than 0.5, what that would be equals to? That would also be 1 by 2. Now I will tell you one more point. So this 1 is 0.5 ahead of mean, right? This 1 is 0.5 ahead of mean. So if your x is greater than 1, then probability is 0.16. And what did I tell you? That your PDF will be symmetric about mean. Your PDF will be symmetric about mean. So what you will do, from mean if you are going 0.4, from mean if you are going 0.5 ahead. So now from mean you will go 0.5 backward. So from mean you are going 0.5 backward. Where you will reach? You will reach at 0. So here what do you see? Greater than 1. Probability is 1 by 6. So here what you will see? Less than 0. This probability will also be 0.16 only. Are you able to understand this point? This probability will also be 0.16 only. I told you the graph is symmetric about mean. So let me draw the graph again. Okay. So I will draw this kind of graph. The graph is symmetric about mean. Let's just say this is the mean, which is mu x. So if I am going alpha ahead, that means if I am reaching here, mu x plus alpha, and there is some probability given that x is greater than, this is the value of x I am taking. If x is greater than mu x plus alpha, then there will be some probability, that is p. So what will happen is that if you go alpha backward, so this point will be your mu x minus alpha. This point will be your mu x minus alpha. mu x minus alpha. So another thing is that these amplitude will also be same. It is not looking like that, but these amplitude will also be same. Along with that, their probability also will be the same. What I mean to say is that whatever the probability that I get here, the same probability I will get here as well. Are you able to understand this point? So the same probability, that means probability of x taking value mu x minus alpha. X should be lesser than mu x minus alpha. Okay, that means the graph is completely symmetric about mean. I went ahead by 0.5, I will go backward by 0.5. So if someone asks me what is the probability such that x is less than 0, they are asking it, yes. In the third question, they are asking it, what is the probability such that x is less than 0? So what that would be? That would be 0.16 only. Are you able to understand this point? Because graph is symmetric about mean. So going 0.5 ahead, then this probability, going 0.5 backward, this probability both will be same. So x less than 0 will be 0.6. Probability of x less than equals to 0 will be 0.6. Next, what they are asking? Fourth question, because second is already done, no? Probability of x less than 0.5. X less than 0.5, which is 1 by 2. X less than 0.5 will be 1 by 2. Next, what they are asking? Fx of 1 they are asking. Fx of 1. That means probability of x taking value less than equals to 1. Probability of x taking value less than equals to 1. So that would be equals to 1 minus 0.16, right? What they are asking? X less than equals to 1. That means this much they are asking. So that would be 1 minus 0.16, that would be 0.84. And next is mode of, first let's solve this inequality. Mode of x minus 0.5 should be less than 0.5. So x minus 0.5 should be less than 0.5 and greater than minus 0.5. So if you add 0.5 in both of them, so x should be between 0 to 1. This is what they are asking. So in the fifth question, what they are asking? They are asking probability of x taking value between 0 to 1. Probability of x taking value between 0 to 1. So this is what they are asking. This is what they are asking. So you know that whole PDF will give you probability equals to 1. The whole PDF will give you probability equals to 1. But if you are getting the probability between 0 to 1, then answer would be 1 minus, this is 0.6, this is 0.6. So 0.16 plus 0.16. That would be 1 minus 0.32, that would be equals to 0.68. Okay. So these are all the answers. And this was the answer of second question. All good, all fine. So everything about Gaussian random variable or other kind of standard PDF we have studied, right? So I hope you enjoyed this lecture. This was a very simple lecture. Just usually it is taught just after the introduction of random variable, but this was a simple topic, so that's why I deal it a bit later on, because in the initial phase we should learn the tougher topic, no? So if we learn the tougher topic in the initial stage, then it will become easy for us. So now all these things will sound very easy for you, right? So this was the topic which was, here we studied about some standard distribution. So we mainly focused on uniform and Gaussian. So after focusing on uniform and Gaussian, we solve the questions of some other standard PDF. So this is also a standard PDF actually. This is also a standard PDF only, but these are not important. Only two important PDF are uniform and Gaussian, and these PDF will again and again keep on coming. And for all of these, we will solve the problem. Mostly we have already solved, and in the end, in the miscellaneous, we will solve more problems, or in the test series as well, you will get some problems. So on all of these, you will get the questions. So here you don't need to remember any standard results. So in this lecture, whatever the standard result that I am asking you to remember, that you need to remember. The most important one is probability of x greater than a, that we studied in Gaussian. This is very, very important. Very, very important. Q of a minus mu x upon sigma x. So you will draw the graph a minus mu x upon sigma x. This is what you need to remember. All good, all fine. So yeah, everything is done. Let's meet in the next lecture. In the next lecture, we are going to study about transformation of random variable. So we will convert random variable x into y or y into x. So we will study about transformation of random variables. Okay, then let's meet in the next lecture. Thank you very much.